Good morning, ma'am. I am Erin Salaveras from Entropy. And now I am going to demonstrate the Newton's law of motion. The first law of motion is often stated as when an object in motion will stay in motion, and an object at rest will stay at rest, unless external forces is applied. This is also called the law of inertia. Inertia means a tendency to remain or continue in an existing state. So I will show you some example that applied law of inertia. I am driving a motorcycle and someone is riding. So as you can see, when I start the motorcycle, our body is moving backward. And when I applied brakes, our body is thrown forward. Because inertia will cause their bodies to continue moving at original speed until their bodies is acted by some force. Another example is this. I have a coin here, a card, and a glass. The coin have enough inertia to resist moving with a piece of paper, but the gravity acts upon it, and the coin falls to the bottom of the glass. Now let's move on to the Newton's second law of motion. But before understanding the second law, we must know first the acceleration. Acceleration is the rate of change in the velocity of an object. So the Newton's second law of motion states that the greater the mass of an object, the more force it will take to accelerate the object. So the equation of this is force equals mass times acceleration, where the unit of force is newtons, mass kilogram, and the acceleration is meter per second squared. So I will show you some example. So here is one of the example of the Newton's second law of motion. Less force applied, small distance. More force applied, more distance. So in order to get more acceleration, you need to apply higher force. So here is another example of the Newton's second law of motion. The harder you kick the ball, the farther it will go. So we are now in the third law of motion. According to the Newton's third law of motion, in every action there is an equal opposite reaction. So it means in every interaction, there are always two forces at play on the body. The magnitude of the two forces is exactly the same. However, the directions are opposite. Thus, they are balance each other. This law is also called a law of interaction. Here is an example of third law of interaction. This simple walking is an example of the third law of motion. So when we are walking, our feet pushing the ground. Our feet are applying a backward force on the ground. The ground in turn applies a forward force on our feet, pushing us forward and making us move. So you can see the action-reaction pair. The action is our force on the ground, and reaction is the force ground on us. The two are equal and opposite. So it's the Newton's third law of motion. In every action, there is an equal and opposite reaction. And that's all the Newton's law of motion. Thank you.